Righto, this is a video on straight line graphs. It's really an introduction, if you like, to straight line graphs. Give you an idea of what it's all about, but also give you the ability to solve some of the kinds of problems that you're going to see on this. All right, so this particular problem says draw the graph of y equals 2x plus 1 on the grid. Okay, well, if you haven't seen graphs before, then probably just worth having a bit of a look at what we mean by this grid. You probably already got the idea of the number line, such that, if we're adding 1 to 3, so we start off at 1, add 3, 1, 2, 3 gets us to 4, so that sort of idea. But here we've not only got our number line going across, but we've got it going up as well. So what it means is any position on this grid here, and of course it could be extended out to 5, 6, 7, as far as we want either way, then any point on this grid can be described by how far along and how far up we're going. So if we take this point, for instance, here, if we just draw that, then that would be 3 along and 4 up. That would be this point, 3, 4. Okay. And similarly, if we could take a point down here, so if we're going backwards, then it's negative. So if we go along -2 and then up 2, we get to this point, and that would be -2 along, or 2 backwards, -2, 2. So that would be that point. And so you can see that all points in this quadrant here are going to be, both parts are going to be positive. Down here, they're both going to be negative, and so on. You can see that. Okay, so that is the idea of your points and your coordinates. And incidentally, we're not just talking about whole number values or integer values here. Then we can pick any point along here, which might be 6.1, 7.3, 6.1. 7.3, for instance, or fractions, or whatever. Okay, so that's what we've got there. I'm just going to clear those down and keep it tidy. Right, so what do we mean by the equation of a line? Well, let's look specifically at this one, y equals 2x plus 1. And this line, this equation defines a line. So for every equation of this form, it's got y's and x's in. We could use other letters actually, but if it's got y's and x's in like this, then it basically describes a unique line. And similarly, a line is defined by the equation, if you see what I mean. Right, so what would that, how would that work? Well, okay, so what we're going to do, let's just have a look at this. We're going to do our conversion. So for different values of x, we're going to find out the value of y. That's going to give us a point, and those points will be, by definition, on the line. So if we're going to calculate this, so if x is -2, then what we've got is 2 times -2 plus 1. 2 times -2 is -4. Add 1 is -3. Okay, so when x is -2, y is -3. Right, so let's just put that on the graph then. So -2 along and -3, which means down. So that's that point there. Okay. Right, we'll just carry on through this process. -1. So that's 2 times -1 is -2 plus 1. That's -1. So -1 in the x and -1 in the y. That's going to be on that line. When x is 0, 2 times 0 plus 1 is 1. So that's going to be that. So that's going to be 0 along and 1 up. Yeah. And 1 is going to give us 2 times 1 plus 1 is 3. Well, there we go. It's good, isn't it? Because it's looking like a straight line, and we're going to find those are going to be 5 and that's 7. 9 actually is just off our grid, in fact. But there we go. We've got those points, and we can choose therefore to draw the line, get in the right place. So that is a line defined by y equals 2x plus 1. Right. So that's good. We only actually need 2 points for a straight line, don't we? So we could just have picked, if we picked this one and this one, they're the furthest apart. So that's going to make it easier to actually get the right line. We could actually look at the 0 points as well, because they're fairly easy to calculate. So when x equals 0, for instance, y is going to be 2 times 0 plus 1. So y equals 1. So that's that point there. That one. Yeah, so that would be that one. And we could then also do, if when y equals 0, what we've got is 0 equals 2 times x plus 1. So we'd have to find the value of x. That gives us that. Well, x equals minus a half would do that. And that would be this point here. So so those are easy to calculate, but in this case they're a bit close together, so it might not actually give us a most accurate line. But in other situations, it's easier if we're putting zeros in. You can do that, but you only need 2 points. That's what I'm trying to say. Right. So now let's just think about another idea here, and that's the idea of the gradient. Now the gradient is we're familiar with that, driving along a road, and a hill has got a gradient, and it might have a steep gradient or a not so steep gradient. So we have the idea of that with this line, and we can probably see here this is fairly steep. But the way we actually measure this is we measure for some distance that we're going along here. Let's increase our x from 1 up to 3. Then what actually happens is that we're increasing our y from 3 up to 7. So so this along is called the run, and going up is the rise. So the rise over the run, so the gradient is measured as the rise over the run. Rise divided by the run, 4 divided by 2 in this case is equal to 2. Right, okay, so that's how we do that. And as this line, if it becomes shallower and shallower, say it's like that, then it's going to be less than 1. In this case, we're going along, how many are we going along 8, and we're going up 2, so it's going to be 2 over 8, quarter, isn't it? If we're coming down like this, then actually as we go along, and in the case 3, we're going along 8, we're actually coming down by 8, So our rise is actually negative. So in that case, the gradient would be a rise of minus 8 over a run of 8. So the gradient would be minus 1. So we've got a whole range of values, but that's an important thing to remember is top left to bottom right gives you a negative. And what about this one here? So this is has got a gradient of 0, hasn't it? It doesn't go up. So the rise is 0 over whatever run we choose to take. So we've got a gradient of 0. Okay, so that's the idea of the gradient. Just clear that out, keep it tidy. The other idea that we need to understand on a straight line is the idea of the intercept. Now, if we're assuming we've written our line in this form with y on the left and some expression in x on the right, then this point here is the value of y. So this on the scale upwards. That's the value of y when x equals 0. Okay, and we call this the intercept. Now, if we look at this particular line, like y equals 2x plus 1, we actually see that it has a this of 2 and this is 1. Well, this is actually the gradient. Call it grad there. And this is the intercept here. Just call it int. Well, not surprising really, is it? Because if x is 0, then this term drops out. So y is going to be 1. So x equals 0, y equals 1 in this case. And of course, this multiplier 2 is the kind of exchange rate, isn't it? So this is saying when every time we increase x by 1, then this whole thing on the right here increases by 2. So that's the gradient. Okay, so if we look at you know, any line, I mean, we'll look at y equals x plus 3. We'll see that's got a gradient of 1, rise over run of 1, and it goes through point 3. So since we know it goes through this point, do it in green, and it's got a gradient of 1, then we know it's also going to go through there and there and there and there, and they're going backwards through there and there and there. So we could draw the line for that equation as well. So and that's basically true. We're going to look at anything at all, can't we? So if we look at the line of y equals x minus 1, well, let's say that's 1x, just so it kind of gets in our mind that the gradient is actually equal to 1, and the intercept is minus 1. So in this case, searching for another color, basically it's going to intercept to minus 1, so it's going to go through there. And then it's got the gradient of 1. So if we just kind of do a little kind of run and then a rise up 3 here. Yeah. So that's a run of 3 and a rise of 3, a gradient of 1. So this graph is going to go through these points. So we can add in the line here. And just extend it up to there. So that would be y equals x minus 1. Usually a good idea just to write it alongside there. So that would be that particular line. Okay, so if we're given the line, we can draw it. We can either calculate lots of points, or if we can't be bothered doing that, just do 2, and that is quite enough. I mean, a lot of questions will ask you to complete a grid of values, so in which case you've got to do all that they ask you. But actually, we only need 2 points, so we could draw a line from 2 points, and we can calculate those 2 points. Or if we're shown a line, we can calculate the gradient and the intercept, and basically we can do either of those or both of those. And if we do both of those, then we can just plug those numbers into our graph, for the gradient and the intercept. And it will give us the equation of the line. Okay, so just a few ideas there as to how we go about solving these problems with straight line graphs. In other videos, we go on to understand what we mean by this point here, which is where x minus 1 and 2x plus 1, where these two lines actually intersect. But that is for another day. So hopefully now you'll be equipped to answer some of these problems on drawing straight line graphs and interpreting them in terms of gradient and intercept. Okay, so thanks for listening.